As you settle comfortably into bed, allow your mind to drift gently outward, beyond the warmth of your room, past the quiet neighborhood and softly upward through the clouds, toward the infinite night sky. Tonight, we'll journey together into the heart of cosmic mysteries, each more fascinating and quietly unsettling than the last. Before we begin this peaceful exploration, let me know, where are you listening from tonight and what time is it there? Imagine you're drifting quietly through space, your body weightless, your eyes gently closed. All around you stretches the infinite darkness, softly dotted with billions of distant galaxies. Yet as peaceful as this seems, you begin to feel a gentle tug, barely noticeable at first but undeniably there. It's as if invisible hands have taken hold of you, softly guiding you towards some unseen destination in the cosmic night. This quiet, invisible pull isn't just imagination. Scientists have long observed that our galaxy, and indeed thousands of others around us, are all softly moving together, pulled subtly yet steadily in a shared direction. They've named this mysterious force the Great Attractor. But here's the unsettling truth. No telescope has ever clearly revealed what the Great Attractor actually is. It's hidden behind the dense veil of our own Milky Way, concealed within clouds of cosmic dust and bright stars, like a whispered secret hidden just beyond hearing. We feel its presence, detect its influence, yet its true nature remains an eerie unknown. Some astronomers softly speculate it might be an immense cluster of galaxies, bound together by gravity. Others gently suggest it's a concentration of dark matter, an invisible, ghostly substance making up most of the universe's mass, quietly shaping reality behind the scenes. And still others wonder if it's something entirely different, something our current science hasn't yet imagined, quietly waiting to be discovered. As you drift gently into the mystery of this cosmic unknown, consider this thought. If something invisible, so powerful yet so hidden, can shape the movements of countless galaxies, what other quiet forces might be subtly guiding your own life's path, unnoticed but ever present? And if the universe has chosen to keep the nature of the Great Attractor just beyond our sight, what other cosmic truths might lie hidden, patiently waiting to be found? Let's move gently onward into the next cosmic mystery. Picture yourself gently drifting through space, gliding softly past galaxies, stars, and shimmering nebulae. Their subtle glow creates a quiet, comforting pattern, like gentle lights guiding your way through the cosmic night. Yet slowly you begin to notice something strange. The galaxies around you grow fewer, the stars quietly fading away until suddenly, you find yourself suspended within an unsettling emptiness, vast, silent, and unimaginably dark. Welcome to the Boötes Void, one of the largest and most mysterious empty spaces ever discovered in the universe. To grasp its scale, consider this analogy. If galaxies were houses, the Boötes Void would be like suddenly stumbling upon an enormous, empty landscape, stretching millions of miles in every direction, with only a handful of lonely structures scattered across its barren expanse. In cosmic terms, it's roughly 330 million light-years wide, and contains far fewer galaxies than expected, quietly defying our current understanding of cosmic distribution. Scientists have softly struggled to explain this profound emptiness. Some suggest that the void might be the aftermath of ancient cosmic collisions, gigantic gravitational interactions quietly pushing galaxies away, creating an immense hollow space. Others theorize more quietly unsettling ideas. Perhaps dark matter, this invisible, mysterious substance, has subtly sculpted this vast nothingness, gently clearing a huge region of visible matter. And then there are those who ponder if we might be glimpsing something even more profound, an unknown cosmic phenomenon softly defying the rules we've always assumed to be universal truths. What if the Boötes Void isn't simply an absence of galaxies, but rather a hint that our universe itself might quietly contain secrets hidden in darkness, just beyond our current understanding? As you softly ponder the silence of this cosmic emptiness, consider this thought. Perhaps the universe is showing us something here. That emptiness can hold as much mystery, meaning, and significance as the brightest star. And if a vast region of space can quietly challenge our fundamental understanding of reality, what other unsettling secrets might the universe still hold, silently awaiting discovery? Let's drift further now toward another quiet mystery. Picture yourself floating softly in the middle of a vast, quiet ocean. Far from any shore, you're gently rocked by calm waves beneath an endless sky. You'd assume you were drifting freely, governed only by the gentle currents around you. But now imagine something strange, something subtle yet unsettling. A force you can't see or fully sense is quietly pulling you, guiding you steadily and inexorably toward an unknown horizon beyond your sight. This mysterious, invisible tug is exactly what astronomers have detected happening to entire clusters of galaxies in our universe. They call it dark flow, a quiet, gentle name for something deeply perplexing. Galaxies billions of light-years away are moving together, softly pulled in the same unexpected direction. But here's the unsettling mystery. There's nothing observable in our visible universe powerful enough to cause such a unified movement. What, then, could be gently tugging these massive cosmic structures along? Some scientists whisper quietly of the possibility that something beyond our observable universe, perhaps another cosmos or dimension entirely, is exerting this delicate yet irresistible pull. It's as if we're observing the subtle ripples caused by a stone dropped into a pond we cannot see, or feeling a gentle breeze from an unseen open door. This softly unfolding mystery challenges our most basic assumptions about reality. It gently suggests that what we can observe might be just the tip of something far greater, quietly hidden behind the veil of our cosmic horizon. As you drift further into the soothing darkness of this idea, ask yourself this quiet, fascinating question. If entire galaxies can feel the gentle pull of something beyond their perception, could our own lives also be quietly influenced by forces we've yet to detect or even imagine? And if the universe truly extends beyond our sight, what other mysteries might it hold, waiting patiently for us to discover? With this thought, let's gently float into our next cosmic enigma. Imagine yourself floating quietly in complete darkness. There's no sound, no movement, just calm, infinite emptiness. Then suddenly, from nowhere, everything around you bursts gently outward, expanding in every direction at speeds so extraordinary they're beyond comprehension. In less than a blink, a region smaller than an atom softly stretches into something unimaginably vast. This gentle explosion doesn't destroy. It creates, softly birthing everything we know as reality. This is the baffling mystery known as cosmic inflation, a brief but monumental event scientists believe occurred mere fractions of a second after our universe's birth. But here's the fascinating part. No one truly knows what triggered this astonishing moment or why it began, or ended, in the way it did. Cosmic inflation quietly defies our understanding, softly whispering hints about deeper laws of physics we have yet to uncover. Think of it like gently stretching a balloon from tiny to enormous in an instant, but with no visible breath, no clear force inflating it. This mysterious energy, whatever it was, expanded the universe faster than the speed of light, something impossible under normal conditions. Yet it happened, and the subtle echoes of this event can still be heard today in the gentle glow of cosmic background radiation. Scientists gently debate the true nature of this mysterious force. Some softly wonder if cosmic inflation points toward multiple universes, each quietly inflating in their own unique ways, perhaps existing alongside ours, silently hidden from view. Others consider the unsettling idea that our universe was created spontaneously from nothing, a quantum fluctuation softly blossoming into everything we see. As you gently reflect on this cosmic puzzle, consider this quiet thought. If the birth of our universe relied on a force so mysterious and unknown, What else in your own life might quietly depend on forces you cannot see or fully understand? And if reality itself began with something as beautifully improbable as cosmic inflation, what other impossible wonders might quietly await discovery? Now let's softly drift onward, to uncover yet another cosmic mystery together. Imagine gently drifting through the quiet blackness of space, surrounded only by the faint glow of ancient cosmic light. This soft, subtle glow, the cosmic microwave background, is the oldest light we can see, a gentle whisper from the earliest moments after the universe's birth. It fills the cosmos uniformly, a serene echo of creation itself. But as scientists softly examined this ancient whisper more closely, they found something quietly unsettling, something they call, with a touch of playful mystery, the axis of evil. The cosmic microwave background should appear uniform and random, like ripples scattered gently across a pond. Yet hidden within it is a strangely ordered alignment, as if someone quietly drew an invisible line through the heart of the cosmos. It's as though the universe is subtly arranged around a specific direction, defying everything we thought we knew about cosmic randomness. Why this alignment exists is softly baffling. Some scientists gently suggest it might be a simple cosmic coincidence, an accidental symmetry in the fabric of reality. Others quietly speculate it could indicate something much deeper and more profound. Perhaps our universe is not quite the impartial random canvas we once believed. This gentle yet disturbing thought raises deeper questions. Could our universe have a hidden structure, quietly guiding the shape and destiny of everything within it? Or might we be observing subtle signs of something even more extraordinary, like hints of other universes softly touching our own? As your mind floats quietly toward sleep, consider this subtle mystery. If the universe itself is not as random or impartial as it seems, could there be hidden patterns shaping our own lives as well, gently nudging us toward destinies we can't yet perceive? With this soft contemplation, let's continue our gentle drift deeper into the cosmos, toward another peaceful yet profound mystery. Imagine standing alone on a soft, sandy shore at night, gazing up at a sky filled with countless shimmering stars. Each tiny point of light represents a world. A sun perhaps much like ours, surrounded by planets. With billions of galaxies, each containing billions of stars, the universe softly whispers one profound question. If life is truly abundant in the cosmos, then why do we find ourselves quietly alone? This gentle but unsettling mystery is known as the Fermi Paradox, named after physicist Enrico Fermi. He once asked simply and softly, "Where is everybody?" It's a question that resonates deeply because if the universe is so vast and conditions for life so plentiful, then logically civilizations should be widespread. Yet we've detected nothing, not a single confirmed signal from another intelligent civilization. Scientists have softly proposed many theories to explain this quiet cosmic silence. Perhaps advanced civilizations exist, but their technology or ways of communication are so radically different that we cannot recognize their signals. Much like trying to spot a whisper in a crowded, noisy room. Or perhaps intelligent species inevitably face a quiet barrier. Some unknown, unavoidable obstacle that prevents civilizations from becoming spacefaring, leaving us quietly isolated. There's an even more intriguing possibility, that we might be deliberately left in silence. What if older, wiser civilizations have chosen to quietly remain hidden, patiently observing younger worlds like ours from afar, silently waiting until we're ready? It's a humbling thought, that we might not yet be considered mature enough for cosmic conversation. As you softly contemplate this deep cosmic silence, consider this gentle reflection. Maybe the universe isn't silent at all. Maybe we just haven't yet learned how to truly listen. Perhaps one quiet day, we'll finally hear a gentle whisper from the stars, softly revealing we were never truly alone. And as you drift deeper into this mystery, gently ask yourself, If life exists quietly beyond our reach, what could we learn from them? And what quiet truths might they share about our place in the universe? Now let's continue drifting softly onward to the next cosmic enigma. Imagine softly drifting across a vast, endless ocean, under a perfectly smooth sky. Everywhere around you, the water feels gently warm and reassuringly uniform. But then, without warning, you drift slowly into an unexpected patch, distinctly colder, eerily quiet, as if something unseen had passed through here, leaving behind only the whisper of its presence. In our universe, astronomers have found something remarkably similar. A vast, mysterious region known simply as the cold spot. Stretching hundreds of millions of light-years across, this subtle yet enormous anomaly appears unusually empty and distinctly colder than its surroundings in the cosmic microwave background, the gentle glow left over from the universe's birth. What could cause such a strange, vast void of chilliness in an otherwise evenly warm universe? Scientists softly suggest a variety of explanations. Some wonder if it's merely a cosmic accident, an incredibly rare but natural fluctuation in the universe's birthlight. Others quietly propose something more unsettling. Perhaps this cold spot is evidence of a collision, a gentle bruise left behind by another universe quietly pressing against ours. Could this be the softest whisper of evidence supporting the existence of parallel universes, subtly touching our own reality? Yet despite careful observation, the cold spot continues to elude definitive explanation, quietly defying our best theories. It remains a cosmic enigma, softly whispering of possibilities far beyond current human understanding. As you drift gently toward sleep, let your thoughts float toward this quiet question. If something as vast and peculiar as the cold spot exists undetected until recently, what other subtle cosmic mysteries might we be gently drifting past without even noticing? With this quiet curiosity in mind, let's continue softly onward, toward yet another gentle mystery waiting patiently to be explored. Imagine you're gently floating through space, surrounded by serene silence, the cosmos softly lit by distant, shimmering galaxies. Suddenly, a flash, a bright, powerful burst of energy lasting only a tiny fraction of a second, ripples silently through the darkness, powerful enough to cross billions of light-years. Before you can fully grasp what you've seen, it quietly fades away, leaving no trace, no explanation, just a deep, lingering mystery. These fleeting signals, known as fast radio bursts or FRBs, are one of the cosmos's most intriguing puzzles. Scientists first detected them by chance, softly capturing brief pulses of radio energy from deep space. Despite being incredibly powerful, briefly outshining entire galaxies, their origin remains completely unknown. Picture standing on a quiet shore, watching gentle ripples form suddenly in a perfectly still lake. You turn around expecting to find a stone or pebble tossed by someone nearby, but the shoreline remains empty. There's no one there. In the same way, FRBs arrive without warning, leaving astronomers puzzled by the invisible force behind these mysterious cosmic ripples. Could they be signals from massive neutron stars colliding somewhere across the universe, their brief encounters briefly lighting up the cosmos? Or perhaps they're the remnants of exploding stars, gently whispering their last messages across unimaginable distances. Even more intriguingly, some quietly speculate these bursts could hint at artificial sources, signals crafted by civilizations far beyond our reach, gently reaching out across the void. As you softly reflect on this cosmic puzzle, consider this quiet thought. If brief signals from unknown places in the universe can reach us here on Earth, what other quiet messages might we be missing every day? Hidden whispers in the vastness waiting patiently to be heard? Now let's drift quietly onward, toward yet another fascinating mystery hidden among the stars. Imagine yourself standing quietly at the edge of a calm, expansive lake beneath a softly glowing twilight sky. The water before you gently ripples outward, expanding steadily and silently toward the distant horizon. It feels serene, peaceful even, until you realize something unsettling. The lake isn't merely expanding, it's slowly but surely accelerating, rippling outward faster and faster, subtly but inevitably pulling itself apart. In the cosmos, something remarkably similar is happening right now. Astronomers call it dark energy, an invisible, mysterious force softly woven through the fabric of our universe, quietly pushing galaxies apart. But the unsettling truth is that we understand almost nothing about it. All we know is that it's there, silently accelerating the expansion of space itself, gently pulling galaxies away from each other at speeds growing ever faster as time moves on. This quiet phenomenon raises profound and unsettling questions. What exactly is this phantom energy hidden in plain sight, shaping the fate of everything we know? Could it eventually stretch space itself so much that galaxies, stars, planets, even atoms themselves, are softly torn apart, dissolving gently into a cold and empty cosmos? Scientists whisper cautiously about possible futures. Perhaps a gentle cosmic isolation where galaxies drift too far apart to ever see each other again. Or perhaps something even more profound. A quiet, relentless expansion eventually tearing the very fabric of reality apart in an event called the Big Rip. As your mind softly drifts toward sleep, contemplate this subtle yet profound mystery. If the universe itself is quietly and gently expanding into oblivion, what might this reveal about the nature of existence itself? And is our fleeting moment in this gentle cosmic story merely a comforting pause before something far stranger and more mysterious unfolds? With this softly unsettling thought, let's move quietly toward our next cosmic enigma. Imagine dropping a book into a fire. You watch the pages curl, blacken, and vanish into flame. The words are gone, the ink erased. But physicists will gently remind you, the information isn't truly lost. It's been transformed. Scattered in ash, in heat, in light. In the universe, information is never supposed to disappear. It can change forms, but it should always quietly remain. Now imagine something far more extreme. Not a fire, but a black hole. A place where gravity becomes so strong that nothing, no matter, no light, not even the tiniest thread of information, can escape. At least that's what we thought. This brings us to one of the most quietly unsettling puzzles in all of physics. The black hole information paradox. According to general relativity, once something crosses the event horizon, the boundary of a black hole, it's gone. Forever. Swallowed by darkness. But quantum mechanics, our most accurate theory of the subatomic world, says that can't be. Information can't simply vanish. Not even into a black hole. So, what happens to the details of what falls in? Every atom, every vibration, every bit of identity? If you tossed in a cup of tea or a spaceship or an entire library, do the specifics just dissolve into oblivion? Or is the information still there? Somehow encoded in the swirling edges of the black hole, etched faintly into the horizon itself? Stephen Hawking thought deeply about this. He once proposed that black holes might slowly evaporate over trillions of years through something now called Hawking radiation. But if the black hole evaporates, and the information never escaped, does it die with the hole? Or does it leak out in the radiation in some impossibly scrambled, unreadable form? It's a gentle standoff between two of our most trusted theories. One whispers that information can vanish forever. The other insists it can't. And right now we simply don't know. Some physicists suggest black holes might not destroy information but store it in an unimaginably compressed form. Others believe information might be preserved on the event horizon itself like a hologram, a fragile, ghostly record of everything that's ever fallen in. Still others whisper about baby universes branching off inside black holes, where information lives on, just not in this universe. As your thoughts begin to drift deeper into this paradox, ask yourself this. If the universe guards information so fiercely, does that mean every choice you've ever made, every thought, every moment, leaves behind a permanent trace somewhere? And if black holes truly are the universe's way of pressing pause on reality, what else might they be keeping hidden? Let's drift softly now into the next quiet question the cosmos is still trying to answer. It lasted just 72 seconds. In the summer of 1977, nestled deep within the quiet hum of the Ohio State University Radio Observatory, a signal, brief, powerful, and eerily precise, flashed across the sky. It wasn't static. It wasn't noise. It wasn't a random spike. It was something else. A clean, narrowband radio signal coming from deep space. For a moment, the universe spoke clearly. And then, silence. The astronomer who spotted it, Jerry Emin, circled the reading on the printout and wrote a single word beside it in red ink. Wow. Since that moment, the wow signal has become one of the most mysterious events in the history of astronomy. It matched what scientists expected a signal from an intelligent extraterrestrial civilization might look like. Strong, focused, and from a fixed point in space. It wasn't the kind of noise you get from a star, a pulsar, or a wandering asteroid. It was tight, intentional, clean, but then it was gone. Despite years of scanning the same region of space, over and over again, no signal like it has ever returned. It came once. It never came back. Some say it was simply an Earth-based interference. A military satellite. A stray signal bouncing from the upper atmosphere. But the coordinates didn't quite match, and the strength of the transmission didn't line up with what we know. And besides, those explanations are more comfortable than conclusive. Others whisper quietly about something more. About the possibility that, for just over a minute, an alien intelligence reached out. Maybe not to say hello, but to be heard. Maybe they were testing the water, dropping a whisper into the void, wondering if anyone was listening. And maybe we missed it. There's something unsettling about that, isn't there? That the loudest message we've ever received from the cosmos might have been lost to the static of time. No follow-up. No second signal. No conversation. Just a single word. Well, as you drift off, let that thought hang softly in your mind. If someone out there tried to reach us, and we didn't respond, will they ever try again? And what if, in some other quiet corner of the universe, another civilization received our echo, our single broadcast, our fleeting hello, and quietly wondered the same thing? Let's continue. There's more hidden out there, quietly waiting to be found. Picture the beginning of everything. A soft flash. The quietest explosion birthing all space, time, and matter. The Big Bang wasn't loud. It was a whisper across the fabric of nothing. And from that whisper came particles, and their perfect mirror twins. For every piece of matter, protons, electrons, neutrons, there should have been an equal amount of antimatter. The same, but opposite. If matter is a coin, antimatter is the other side. When they meet, they cancel each other out in a quiet burst of energy, leaving nothing behind but a flicker of light. So here's the unsettling mystery. If the universe created matter and antimatter in equal parts, then where did all the antimatter go? By logic, everything should have annihilated itself in a flash of balance. There should be no stars, no planets, no us. Just silence and symmetry. But clearly, that didn't happen. Somehow, someway matter won. This is called the baryon asymmetry problem. A soft, scientific term for a cosmic imbalance we can't explain. Somewhere in those first few moments of the universe's birth, something tipped the scale. For every billion particles of antimatter, there were 1,000,001 particles of matter. That lonely extra one, that's what makes up everything. Every tree, every planet, every hand you've ever held, every thought you've ever had. All of it built from the tiniest imbalance, as if the universe chose to favor something instead of nothing. Scientists have tried to uncover the reason. They've searched for differences in the way matter and antimatter decay, little asymmetries in behavior that might explain the cosmic betrayal. And though some hints have emerged, they remain faint, like footprints washed away in the tide. Others wonder, was there a subtle bias coded into the laws of nature from the very beginning? A hidden preference that gave rise to existence as we know it? As your thoughts begin to drift, let this idea settle gently in your mind. Everything you've ever known exists because of a tiny, quiet imbalance in a universe that should have erased itself. And if something as vast and meaningful as existence came from something so small, what quiet, invisible imbalances might be shaping your own life even now? Let's float forward, deeper into the darkness, where more of the universe's unanswered questions softly wait. Close your eyes and picture this. You're floating in complete darkness, far beyond the edge of any galaxy, where silence wraps around you like a blanket. There's nothing, or so it seems, but as your vision adjusts, something begins to take shape. Faint, delicate filaments stretch out before you, thin, glowing threads that crisscross the void like strands of an invisible spider's web. You're not alone out here. You're drifting through the cosmic web. At the largest scale imaginable, the universe isn't just a random scatter of stars and galaxies. It's structured, intricately, almost unnervingly so. Galaxies are not evenly spread through space. They form vast clusters, filaments, and sheets, with enormous voids in between. Together, these structures shape something that looks startlingly familiar. A web. A universe-spanning lattice of matter. But here's where it gets strange. The galaxies, the stars, the planets, everything we can see, are just the lights on the strands. The threads themselves, they're made of something we can't see. Dark matter. A ghostly substance that doesn't shine, doesn't reflect, and doesn't interact with light at all. Yet its gravity quietly sculpts the very shape of the cosmos. This hidden architecture, this skeleton of the universe, is what holds galaxies together. Without it, everything would unravel. Our galaxy, your body, everything. And yet we don't know what it is. How do we know it's there then? By watching galaxies move. By seeing how light bends as it passes through these invisible structures. A phenomenon known as gravitational lensing. We see the effect even if we cannot touch the cause. And there's something eerie in that, isn't there? The visible universe, the stars you wish on, the galaxies that fill deep space photos, is only about 5% of what's actually out there. The rest is hidden, silent, sculpting reality without ever revealing its face. So as you begin to fall into sleep, imagine the space between stars not as emptiness, but as the hidden scaffolding of existence. An intricate, unseen architecture quietly binding the universe together like strands of silk in a cosmic dream catcher. And then ask yourself, if everything we see is just the glow clinging to invisible threads, what else might be resting on the web, waiting in the dark just beyond our perception? Imagine the opposite of falling. Instead of being pulled inward by gravity, toward the heart of something dark and hungry, you are pushed outward. Not gently but violently, as if spat from the very edges of reality. Light, matter, time. Everything is flung away from a single point as though the universe is trying to expel something it cannot contain. This is the strange, barely whispered concept of a white hole. If a black hole is a cosmic sinkhole swallowing everything that gets too close, a white hole is its mirror. A theoretical object that nothing can enter and everything is pushed out of. It would be the cosmic reverse of gravity. No entry, only escape. But here's the mystery. White holes are not something we've observed. Yet, they exist purely in the math, emerging as natural solutions to Einstein's equations. Equations that say, if black holes can exist, then under the right conditions white holes should too. Some theories go further. They suggest that a white hole might actually be connected to a black hole, like two ends of a tunnel bending through space and time. A wormhole. Matter falls into the black hole, and is expelled out of the white hole elsewhere. Maybe in another part of the universe. Maybe in another universe entirely. But no one's ever seen one. They remain shadows in the equations. Echoes of what might be. Still, white holes raise a quietly unsettling possibility. What if black holes don't destroy information or matter? What if they're delivering it? And if something out there is spitting matter into our universe, how would we know? Would it look like a sudden burst of radiation? An unexplainable explosion? A star being born with no parent? And deeper still, could the Big Bang itself have been a white hole? Think about that as you drift off. What if the universe didn't begin from nothing, but from somewhere else? Pushed out through a cosmic tunnel. The quiet birth of everything, emerging from the other side of something we've never seen. White holes exist. Where are they now? And more curiously, are they watching us the same way we've watched their darker twins? Let's keep going. The cosmos isn't done whispering. Imagine you're floating through deep space. Silence surrounds you. Then you feel something strange, like brushing your hand against an invisible line. Not a wire. Not a beam. But something impossibly thin, impossibly long, and impossibly powerful. You've just touched a cosmic string. A relic perhaps from the very beginning of time. These hypothetical objects are among the strangest predictions of early universe physics. Not strings like shoelaces or threads, but lines of immense energy stretched across the cosmos. If they exist, they'd be thinner than an atom, yet denser than a mountain. 1 mile of cosmic string could outweigh an entire planet. They're thought to have formed in the earliest fractions of a second after the Big Bang, when the universe was cooling, settling, and shifting, cracks in the structure of spacetime itself like fault lines on a cooling surface. And just like cracks in ice, they could extend endlessly or loop around and reconnect. But what would it mean if these strings exist? If two ever collided, the impact could release so much energy that it would ripple through spacetime, like gravitational waves echoing through the dark. Some scientists believe we may have already detected hints of these ripples, but we're not yet sure. Their presence would rewrite our understanding of the universe's structure. They could help explain why galaxies form where they do, or why the cosmos clumps together in strands and webs. They might even be clues to a deeper level of physics hidden beneath what we can currently observe, like threads holding together the cosmic tapestry. But here's the strange part. We've never seen one. We've never touched one. We've only imagined them through math, theory, and the quiet logic of possibility. And yet, if they're real, they could be all around us. Passing through galaxies, slicing through stars, even brushing gently past the Earth, without leaving a trace. As you drift further into sleep, ponder this. If the universe hides its most powerful structures where we cannot see, what else might be gently shaping reality beneath the surface? And what if the things we think are empty space are not so empty after all? Shall we keep drifting? There's more to uncover. Imagine standing at the edge of a mirror. Not the kind that simply reflects your face, but something far more infinite. You move your hand and the reflection moves too. But what if, somewhere, just beyond the glass, it didn't? What if it made a different choice? A different life, quietly unfolding in perfect silence, just out of reach. This is the haunting beauty of the multiverse hypothesis. The idea that our universe is just one thread in an unimaginable tapestry of realities. In one universe you're reading these words. In another you never found them. In one Earth never formed. In another Earth formed twice. It sounds like science fiction, but modern physics whispers that it might not be. Some interpretations of quantum mechanics suggest that with every decision, every shift, reality splits. A branching of timelines. A soft forking of the path. Other theories speak of bubble universes, each one forming in the chaotic froth of cosmic inflation. Endless little cosmoses, each with its own laws of nature, like distant lanterns flickering across a dark sea. And then there's string theory. It proposes dimensions we can't see or touch, dimensions where other versions of you might quietly exist, walking through days that feel eerily familiar but are never quite your own. It's a staggering idea. Not only that we might not be alone in the universe, but that we might not even be alone in ourselves. But here's what makes the multiverse quietly unsettling. It could mean that everything that can happen has happened somewhere. That every choice you didn't make, every word you never said, still echoes through a parallel version of your life. The regrets, the dreams, the accidents narrowly avoided, all of them playing out gently in the background of a grander, stranger cosmos. And if these realities exist even now, layered invisibly beside ours, how would we ever know? Could déjà vu be a soft bleed-through? Could dreams be echoes from a sister world? Could longing itself be the quiet ache of another self, reaching across a boundary too subtle to name? As your eyes grow heavier, let this question float softly through your thoughts. If the universe is just one possibility in a sea of countless others, then what is this moment you're living now? A chance? A miracle? Or simply one turn among many in a cosmic kaleidoscope that never stops turning? Let's continue and see where the next thread of mystery might gently take us. Imagine staring up at the night sky, eyes gently scanning the quiet stars. Most of them pulse with ancient, predictable rhythms, steady beacons of calm in the darkness. But then, one doesn't. In 2015, scientists studying a star known as KIC 8462852, or more eerily Tabby star, noticed something strange. The light from this distant star was flickering. Not just a little. Not like a planet passing by or a regular dimming event. These dips in brightness were deep, erratic, and unpredictable. Sometimes 5%, sometimes 15%, once nearly 22%. That's like someone turning down a stadium light at random moments, for no clear reason. At first, astronomers considered all the usual suspects. Maybe it was a cloud of comets, dust from a shattered planet, or debris swirling through space. But none of these explanations quite fit. The dimming was too strong, and too strange. So someone whispered a more unsettling idea. What if something massive, something artificial, was orbiting the star? Not a planet, not dust, but a structure. A megastructure perhaps built by an advanced civilization. A vast solar collector, maybe a Dyson sphere, constructed to harness the energy of the star itself. The thought stirred something ancient in us, wonder and fear. Suddenly, Tabby's star wasn't just another distant light. It was a possibility, a question mark in the sky. Not proof of aliens, but a whisper of something we couldn't explain. A moment where science looked into the dark and found silence. A flicker. Maybe. The scientific community stepped back. They urged caution. Probability says it's likely just dust or some natural phenomenon we don't fully understand yet. But probability isn't certainty. And the mystery remains. As you close your eyes tonight, consider this. If another civilization did build something grand enough to dim a star, what does that say about them? Their age, their ambition, their silence? And what if we're not alone, just unseen? What if the universe is full of flickering stars, each hiding a story we haven't yet learned to read? Let's drift deeper. There are still many stars, and many secrets. Imagine a lighthouse, an old stone tower perched alone on a foggy shore. It spins slowly, casting its beam across dark, empty waters. But instead of guiding ships, imagine it's lighting up galaxies. That's what a quasar is. At the center of distant galaxies, billions of light years away, lie objects so bright they outshine everything around them. Entire galaxies fade in their presence. These aren't stars. They're not explosions. They're quasars, the cosmic lighthouses of the early universe. But here's the strange part. We barely see them anymore. Most quasars lived and burned brightly when the universe was young, just a few billion years old. Today their numbers have dwindled. Their light is fading, like echoes from a time we no longer understand. So what are they? At their heart is a supermassive black hole, millions, sometimes billions of times the mass of our sun. As matter spirals in, it doesn't just vanish quietly. It heats up, spins faster, glows with unimaginable energy. Jets of radiation shoot out from the poles, stretching across intergalactic space. They burn so brightly that we can still see them from across the universe, billions of years after the light first began its journey. But no one fully knows how these objects became so powerful, or why they burned so intensely in the beginning only to go silent later. Why were they so common in the young universe, and why did they fade away? Did they exhaust their fuel? Did the black holes go to sleep? Or is something else happening that we simply can't see anymore? Some scientists think quasars might represent a cosmic adolescence, a wild, luminous phase in the life of a galaxy. Others wonder if we've simply missed newer quasars hidden behind dust and darkness, whispering their light in ways we haven't yet learned to hear. And here's the most human part of it. These objects are messages from the past. When you look at a quasar, you're seeing light that left its source before Earth even existed, before the sun formed, before there was such a thing as us. They're cosmic ghosts, still burning in our skies, long after their fire may have gone out. So as you slowly drift into sleep, think about this. What else is still echoing across the universe? What brilliant light, what message, might be quietly passing us by, too distant, too ancient, too mysterious to fully understand? Let's follow the light a little farther, into the next mystery waiting quietly in the dark. We've been listening for so long. For over half a century, vast radio dishes have turned their ears to the stars, straining to catch even the faintest whisper. Computers sort through endless noise looking for a signal, anything structured, anything intentional. We scan nearby stars. We listen in quiet frequencies. We launch golden records into space with our music, our math, our message. We are here. And yet, the universe answers with silence. This is what scientists call the Great Silence. A quiet so deep it begins to feel personal. If the universe is as vast and as ancient as we believe, home to trillions of planets circling billions of stars, then where is everyone? This is the quiet cousin of the Fermi Paradox. It's not just that aliens haven't visited us. It's that no one's left a message. No ruins. No beacons. No cosmic artifacts. Just the soft background hiss of the universe, stretching out like an endless night. Some suggest the answer lies in distance. That civilizations are simply too far apart to ever reach each other. That light itself takes too long to travel between stars. Others propose a darker idea. Perhaps intelligent life always destroys itself before it learns how to speak across the stars. Wars, technology, fragility. Then there's a more haunting possibility that everyone is out there, and they're choosing not to speak. Because something happens to those who draw too much attention. A quiet cosmic rule. A shadow in the dark. Do not announce yourself. Or maybe we're just early. Perhaps life is still waking up across the cosmos, stretching slowly into consciousness. Maybe we're the first to listen. The first to wonder. The first to ask. As your thoughts drift gently between stars, ask yourself this. Is silence more terrifying than noise? And if we are truly alone in this vast and beautiful universe, what does that make us? Let's drift further now into the stillness between worlds, where mysteries remain softly unanswered. Imagine walking through a familiar room, your bedroom perhaps. The walls, the floor, the air around you, it all feels still, solid, understood. But now imagine a quiet voice whispering, half of what's in this room isn't visible. You're moving through something vast and unseen. This isn't science fiction. It's the reality of our universe. Roughly 85% of all matter in the universe is invisible. It doesn't emit light. It doesn't reflect it. It doesn't absorb it. You can't touch it, taste it, or hear it. And yet, it's there, silently shaping the cosmos. Scientists call it dark matter, a name as mysterious as the substance itself. We discovered it not by seeing it but by feeling its pull. Galaxies spin faster than they should. Stars on the outer edges should fly off like loose screws, but they don't. Something unseen holds them in place. An invisible hand with an unmistakable grip. But what is it? We've pointed our telescopes at it. We've tried to trap it in underground detectors. We've smashed particles together at near light speed hoping to glimpse it. And yet, nothing. It slips through everything, quietly avoiding interaction like a ghost walking through a crowd. Some theories suggest it's made of exotic particles, weakly interacting massive particles or WIMPs, strange cousins of the ones we know but shy. Others whisper of axions, sterile neutrinos, or entire hidden sectors of physics we've yet to unlock. A few even suggest that dark matter isn't matter at all, but a sign that gravity itself behaves differently on a cosmic scale. But for now, it remains a gentle riddle. Dark matter doesn't seek attention. It doesn't burn, doesn't collide, doesn't speak. But its fingerprints are everywhere. In the way galaxies form, in the shape of the cosmic web, in the silent architecture of the universe. And here's the quiet truth. If dark matter vanished tonight, the universe as we know it would fall apart. Galaxies would unravel. Stars would scatter. Would cease to be. So as you drift into sleep, ask yourself this. If the very foundation of the cosmos is something we cannot see, what else might be quietly supporting your life, your thoughts, your path, just beyond your perception? Let's continue gently. The cosmos is still holding its breath. Imagine a black hole, not as a violent monster but as a sleeping giant. Silent, though. A sphere of absolute darkness that lets nothing escape. Not light, not sound, not time. For decades we believed that once something fell past its edge, its event horizon, it was gone forever. Swallowed by gravity. Erased. But then Stephen Hawking proposed something radical. Something softly defiant. He suggested that black holes leak. It starts at the edge. Not inside the black hole but just outside of it. In the emptiness of space, particles and antiparticles constantly flicker into existence in pairs, like whispers of reality born from the vacuum. Normally they annihilate each other almost instantly. But near a black hole something strange can happen. One particle falls in. The other escapes. And that escaping particle? It becomes real. It becomes energy. It becomes what we now call Hawking radiation. Over time, millions, billions, trillions of years, a black hole can slowly evaporate, fading away particle by particle. Not with a bang but with the gentlest sigh. A cosmic giant disappearing not in violence but in silence. But here's the real mystery. If black holes can evaporate, what happens to all the information they once held? Every planet, every star, every fragment of matter that fell inside. Does it somehow get released in this radiation? Or is it lost forever? The paradox remains. Hawking radiation opened a door, but behind it is a darker corridor. Some believe the information is encoded in the escaping energy, just impossibly scrambled. Others think the information is burned into the event horizon itself, a cosmic skin that remembers everything. And still others quietly wonder if the information simply dies. So tonight, as you drift deeper into sleep, consider this. Even the most terrifying objects in the universe, the ones that swallow light and twist time, may still end not in dominance but in disappearance. And if even black holes fade, what else might be impermanent? Let's continue. The universe has more to whisper. Picture this, you're lying in bed, calm, quiet, drifting. The world outside is still. Stars hang in the sky like whispers of ancient fire. Everything feels safe. But deep beneath that silence, beneath every atom, every breath, every star, lurks a fragile truth. A soft, terrifying possibility that the very fabric of reality may not be as stable as we believe. This is the idea behind vacuum decay. A theory so quietly disturbing it doesn't explode, it unfolds. According to quantum physics, everything in the universe exists in a state called a vacuum state, essentially the energy level of empty space. Our universe appears to exist in what scientists call a false vacuum, a state that seems stable, but might not be the true lowest energy state possible. Imagine standing on a high ledge that feels flat, until you realize it's actually a cliff edge and far below there's a valley you didn't know was there. If we're in a false vacuum, there's a chilling implication. Our universe could one day spontaneously collapse into a more stable version of itself. A true vacuum. No warning. No sirens. Just a quantum event beginning somewhere in the dark. A tiny bubble of true vacuum appears. It expands at the speed of light. And as it passes, it rewrites everything. Every law of physics. Every atom. Every planet, star, memory, gone. Not with fire. Not with violence. But with silence. Rewritten by new rules. New constants. A new universe unfolding inside the shell of the old. And we'd never see it coming. This isn't science fiction. It's quietly woven into some versions of the standard model of particle physics. And while current measurements suggest we might be safe for billions of years, the uncertainty lingers. Vacuum decay could be unimaginably far away, or already quietly on its way. But here's the strange beauty in it. If such a collapse did occur, it wouldn't be evil or cruel. It would simply be change. The universe shedding one skin for another. A cosmic sigh. As you drift into the dark, ask yourself, what would it feel like to live in a reality that might at any moment dissolve and start again? Would we live differently, knowing that everything, even the rules themselves, could one day vanish without a sound? Or is that already true, in ways we haven't yet noticed? Let's keep floating forward into even deeper questions that space refuses to answer. Imagine a lighthouse floating in the blackness of space. It doesn't flicker or falter. It pulses. Like a heartbeat. Perfect. Steady. Predictable. These cosmic lighthouses are called pulsars. Rapidly spinning neutron stars that sweep powerful beams of radiation across the cosmos like clockwork. Some spin hundreds of times per second, each pulse so consistent you could set your watch to them. They are, quite literally, some of the most precise timekeepers in the known universe. And that's why it's so strange when one skips a beat. Every so often, astronomers notice something quietly disturbing. A pulsar, once steady as a metronome, suddenly stutters. The rhythm shifts. The timing slips. Not by much, sometimes just a fraction of a millisecond. But when something that precise breaks its pattern, the universe leans in. We call these events glitches. But no one knows exactly what causes them. Some scientists believe the crust of the neutron star, the densest matter in the universe outside a black hole, might be shifting slightly like a tectonic plate cracking. Others whisper of deeper forces, perhaps interactions with dark matter, or nearby gravitational waves rippling through spacetime. Then there's the more unsettling idea that something external, something we don't yet understand, is quietly interfering. That these perfect clocks of the universe are being subtly nudged by something else. And in 2023, astronomers noticed something even more bizarre. A pattern. A group of pulsars, separated by millions of light years, were all showing slight changes in timing in sync. As if the whole universe had exhaled at once, and the stars took note. It raises a strange, quiet question. If these cosmic clocks are being influenced by something, what is it? And could we be feeling it too? As you let that question settle in your mind, drifting gently towards sleep, consider this. In a universe filled with perfect rhythms, what does it mean when something skips a beat? Let's move forward. The mysteries only deepen from here. Look up at the night sky. The stars you see are scattered across time. Some shining from just a few years ago, others beaming at you from millions or even billions of years in the past. The deeper you stare, the farther back in time you're peering. But here's the eerie part. We are living in a very specific moment. One that seems strangely, perfectly timed. Right now, from Earth, the universe appears balanced in a way that shouldn't last. The amount of dark energy, the invisible force pushing the universe apart, is currently just enough to counteract the gravity pulling everything together. Not too strong, not too weak. Just enough to allow galaxies, stars, planets, and life to exist. In fact, if you measure the energy densities of matter and dark energy today, they're oddly close, even though they've evolved at vastly different rates. This strange situation is known as the cosmic coincidence problem. Why should we exist in the exact cosmic window when this balance is happening? 100 billion years from now, dark energy will dominate completely. Galaxies will slip out of view. The universe will grow cold and quiet. And 100 billion years ago, matter ruled completely, and the delicate structures we rely on today, stars, elements, biology, hadn't yet formed. Yet here we are, right in between. The only time where intelligent observers like us could exist and see this balance. Some scientists argue that it's not coincidence, it's selection. Of course, we live at the time when it's possible to observe the cosmos. That's the only time we could be here. Others whisper of deeper truths, that maybe this balance isn't chance at all but a clue. A soft fingerprint left behind by the architecture of reality, or the quiet hint of design. Or perhaps, in the vastness of the multiverse, countless universes exist with all kinds of ratios, and we simply drew the cosmic lucky number. As you drift closer to sleep, let your mind hold this one quiet question. If the entire universe seems perfectly tuned for us to observe it, then what exactly does that say about us? And are we the ones watching the universe? Or is it softly watching us back? We think we know what gravity is. You drop something and it falls. The moon pulls at the tides. Planets orbit stars. Feels simple, predictable. A force that binds everything together. A quiet glue holding the universe in place. But the more we stare at gravity, the stranger it becomes. Newton gave us the first language for it. Objects pull on each other with invisible strings. The larger the mass, the stronger the pull. And it worked beautifully for centuries. But then came Einstein. And he said, no, it's not a force at all. Gravity, he proposed, is the bending of space and time itself. Massive objects curve the fabric of the universe, and smaller objects simply follow those curves, like marbles spiraling down the sides of a soft funnel. A planet isn't being pulled around the sun. It's rolling along a warped path drawn not by force, but by shape. It was elegant, revolutionary. But even Einstein's version, so beautifully mind-bending, leaves questions. Because when we zoom in deep into the smallest particles, gravity becomes a ghost. It doesn't play well with the quantum world. The math breaks, the theories unravel. And so, physicists began to wonder, what is gravity really? Could it be a byproduct of something deeper? An illusion born from entangled particles? Or perhaps it's not fundamental at all, but emergent, like temperature rising from the collective behavior of molecules. Not a law of nature, but a consequence of something else. And then there's dark matter. The galaxies we observe spin too fast to be held together by visible gravity alone. So we infer the presence of something unseen, something adding to the gravitational pull. Something invisible. Or maybe it's not missing matter, but misunderstood gravity. Maybe the rules change out there in the quiet edges of the cosmos, where light fades and mystery begins. As your body sinks softly into sleep, let this idea curl around your thoughts. What if gravity, the thing that keeps your feet on the ground, that guides planets, that holds galaxies together, isn't what we think it is? What if it's only the shadow of something else? And if the most familiar force in your life is quietly something else entirely, How much of reality have we yet to truly see? Let's keep drifting. The universe still has more to whisper. It begins without warning. Somewhere far beyond the edge of our galaxy, a massive star collapses into itself. Its core folds in like a dying breath, and for a brief moment, just a few seconds, two beams of unimaginable energy erupt outward, slicing across the fabric of the universe at nearly the speed of light. If you were watching from a safe distance, you might see nothing at all. But if one of those beams was pointed toward you, you'd be witnessing the most powerful explosion since the Big Bang. They're called gamma-ray bursts. Silent, sudden, cataclysmic. For a moment, they outshine entire galaxies. A single burst can release more energy than our sun will produce over its entire 10 billion-year lifetime. In just a few seconds, they can sterilize entire star systems, stripping planets of their atmospheres and turning oceans into steam. And the most unsettling part? We don't fully understand them. Not entirely. Not yet. Some gamma-ray bursts are short, others long. Some are believed to come from collapsing stars. Others from the merger of neutron stars, tiny, impossibly dense remnants of dead suns spiraling into each other until they slam together in a final cosmic breath. But even with decades of observation, their exact causes remain partially cloaked in mystery. What we do know is this: if a gamma-ray burst ever occurred nearby, and by nearby, we mean within thousands of light years, it could quietly end life on Earth. Not with fire. Not with explosions. But with an invisible wave of energy that would erase our protective ozone layer, leaving the planet exposed to cosmic radiation. No warning. No sound. Just silence. But don't let that thought keep you awake. Because while gamma-ray bursts are terrifying in power, they're also profoundly rare. In the great quiet of the universe, they are the exception, not the rule. And in their rarity, they remind us of how fragile everything truly is, and how lucky we are floating here in the stillness just far enough away from the fireworks. So as you drift deeper into the dark tonight, let your thoughts wander to that silent storm of light, raging for mere seconds on the edge of the cosmos. Bright enough to burn entire systems. Brief enough to vanish before you even know it happened. And still, we're here. Let's move gently onward now, toward the next cosmic whisper still waiting to be heard. Imagine standing in the middle of a crowded room, hundreds of people quietly moving past you, brushing your shoulders, breathing the same air, yet you see no one. You feel nothing. You're surrounded, but completely unaware. Right now, in this very moment, billions of ghost-like particles are drifting through your body every second. They move through your skin, your bones, your memories. Not one of them slows down. Not one of them stops. These are neutrinos, tiny near-massless particles born in the hearts of stars in the earliest fires of the cosmos. And among them is something even more ancient, more quiet, more forgotten. The cosmic neutrino background is perhaps the oldest whisper of the universe still echoing through time. These neutrinos were born less than 1 second after the Big Bang, long before atoms formed, before light could travel, before the universe was even transparent. They are the silent witnesses to the very beginning, still gliding effortlessly through the cosmos, undisturbed, unchanged, unseen. Unlike light, which paints the universe with color, neutrinos pass through everything without a trace. No telescope sees them. No camera records them. And yet they are everywhere. Right now, nearly 300 relic neutrinos from the dawn of time pass through every cubic centimeter of space, including the space inside you. They are the cosmic ghosts of creation. And yet, we've never directly detected them. We only know they exist because their presence completes the puzzle. Without them, our equations fall apart. Our understanding of the early universe collapses. But they remain hidden, quiet passengers in the story of everything. Scientists have built underground detectors the size of cathedrals, buried beneath mountains and oceans, waiting for just one of these ancient neutrinos to softly leave its mark. But so far, nothing. Like a whisper too faint to ever be heard, they drift on. It's a strange feeling, isn't it? Knowing the oldest substance in the universe is quietly moving through you right now, without a sound, without resistance, without the faintest sign. And maybe the most humbling thought of all. These neutrinos were already ancient when the first stars lit up. They were already passing through galaxies before galaxies even existed. They've been with us the entire time, and we still don't know what they really are. So as you close your eyes tonight, gently floating into sleep, imagine those silent travelers slipping through your thoughts like moonlight through a window. The first messengers of time. The forgotten breath of creation. Still here. Still waiting. And ask yourself, what else might be all around us, passing through unnoticed, shaping reality in ways we haven't yet begun to see? Let's drift quietly now into the next forgotten mystery. Close your eyes and imagine two titanic giants, spinning silently in the darkness. Each one is a black hole, an abyss where time slows, light bends, and nothing escapes. They orbit each other in a quiet, deadly dance, drawing closer with every turn. No sound, no flash, just gravity growing tighter, stronger, until finally the two merge. And in that moment, so brief, so violent, it's as if the fabric of reality itself trembles. When black holes collide, they send ripples through space-time. Not metaphorical ones, real, physical waves in the very structure of the universe. These are gravitational waves, and for over 100 years they were only a prediction. A whisper in Einstein's equations. Unseen, unheard. Until recently. In 2015, for the first time in human history, we heard the universe ripple. Instruments on Earth, so precise they could detect distortions smaller than a proton, recorded the distant echo of two black holes merging more than 1 billion light-years away. The signal lasted less than a second. But in that second, more energy was released than in all the stars of the visible universe combined. And yet it was silent. No explosion. No fireball. Just a gentle chirp, like the universe exhaling. But here's the mystery. Black hole mergers don't just release energy. They raise questions. What happens inside that final union? When two singularities, points of infinite density, merge, what becomes of them? Is the result just a bigger black hole? Or something stranger? Could these collisions unlock shortcuts through spacetime? Create gateways? Leave behind exotic structures in the fabric of reality we don't yet understand? Some physicists speculate that the violence of these mergers might produce echoes. Subtle, repeating ripples that defy classical physics. If true, it would mean black holes are not the silent tombs we thought, but something even more complex. Something alive with hidden structure, quietly recording the memory of everything they've devoured. And as we detect more of these cosmic collisions, we might be listening to the universe telling us its secrets. One soft wave at a time. So as you drift further into the stillness of night, ask yourself, if we can now listen to the universe, what other stories has it been trying to tell us all along? Let's keep listening as the darkness whispers more. Close your eyes and imagine drifting slowly upward, past clouds, past stars, past the clustered galaxies and cosmic webs, until there's nothing left but quiet. And now ask yourself a question that has haunted physicists and dreamers alike. What shape is the universe? Sounds simple, childlike even. A question you'd ask while lying under the stars. But the answer touches the deepest threads of space and time. We often imagine the universe as a giant sphere, a bubble with galaxies floating inside. But that idea comes from our intuition, not from what the cosmos has whispered to us. Because in truth, the universe might be flat, or gently curved, or even boundless in a way the human mind struggles to picture. According to Einstein's theory of general relativity, the shape of space is determined by its contents, by the matter and energy that live within it. And depending on the balance between gravity and the universe's expansion, space itself can take on one of three quiet forms. Could be closed like the surface of a sphere. If you traveled far enough in one direction, you'd eventually end up where you started, looping around reality like a cosmic circle. This would mean the universe is finite, but unbounded, like living on the surface of a balloon with no edges. Or it could be open like a saddle, curving outward forever. A universe that spreads wider and wider, thinning into emptiness as it expands. And then, it could be flat. Not flat like a sheet of paper, but flat in a mathematical sense. Infinite. Uniform. Balanced on the edge between collapse and endless expansion. Most of the evidence we have suggests that this might be the shape we live in. A flat universe, stretching forever in all directions, with no center, no edge, no outside. But even here the mystery lingers. Because how do you know the shape of something from the inside? How do you measure the curvature of a room when the walls are made of stars, and the ceiling is stitched with time? And if we do live in a flat, infinite universe, what lies beyond the farthest thing we can ever see? Does the shape of reality hide deeper truths we haven't yet imagined? As you drift further into rest, let that question float with you. If the universe has a shape, does it also have a purpose? Or are we simply passengers, riding the curve of something we'll never fully grasp? Let's follow the arc of space a little further, and see what mysteries lie just beyond the next bend. Close your eyes and picture the universe, not as it is now but as it might be, in the end. Not tomorrow, not in a million years, but in some quiet, unreachable future, long after every star has burned its last flame, and every galaxy has drifted into the dark. Everything that begins must end. And the cosmos, vast, expanding, ancient, whispers this truth in silence. But what will that ending look like? Cosmologists have long speculated on the ultimate fate of everything. Some theories are gentle, others quietly unsettling. One possibility is the heat death, a slow, inevitable fading. The universe keeps expanding, galaxies growing ever farther apart, stars dying one by one, until all energy spreads too thin to sustain movement or life. A perfectly even, cold darkness. No light, no sound, just stillness. Forever. Another ending is called the Big Rip. If dark energy, the force accelerating cosmic expansion, grows stronger over time, it could tear galaxies apart. Then stars. Then planets. Then atoms themselves. Everything gently unraveled until the very fabric of space is undone. Or perhaps the universe will collapse in on itself. A big crunch. Gravity eventually overcomes expansion, pulling everything back together. Galaxies drawn inward, heating, colliding, compressing into one final point. A reversal of the Big Bang. A breath exhaled, now slowly being drawn back in. And there's one more idea. The cosmic rebirth. That perhaps after the universe ends, however it ends, it begins again. A new Big Bang. A new timeline. A new version of everything rewritten from the ashes of what once was. Like a cosmic inhale and exhale repeating forever. But here's the quiet truth, we don't know. We're passengers in a story still being written. Drifting through a chapter we barely understand. We exist during a rare sliver of time where stars still burn and galaxies still shine. And maybe that makes our moment more precious, not less. Because we're not meant to control the ending, only to witness this page of it. To wonder at the mystery of it all. As you drift off tonight, think of this. The universe, vast and ancient, has carried you safely through time. Every breath you've taken, every heartbeat, is happening in a cosmos still unfolding. And even if the stars someday go out, you were here while they burned. Let's softly continue. More mysteries are waiting.